We've already seen what are referred to as associations in a diagram. Drawing any kind of line between objects simply suggests there is some kind of interaction. One object knows about or interacts with a different object. We can add a note to explain this. It might just be that one object is calling a method of another object. But we can get more specialized with what we're trying to illustrate. We've seen the way already that we show inheritance with the empty arrow pointing at the superclass or parent class. And we have another couple of terms here to explore and their supporting diagrams. We're going to talk about aggregation and composition. Both are very long words for simple ideas, and they describe an obvious relationship between our objects, that one object can often be built of other objects. So aggregation is often referred to as a has-a relationship as opposed to the is-a relationship of inheritance. We would never say something like a customer is a address, but we might say a customer has a address, or a car has a engine. More correctly, I'd say a car has an engine, but this will work. Now, has a can implicitly suggest has many, so a bank has many bank accounts, or a university has many students. But what we're exploring is the has-a relationship, not the is-a relationship. In UML, we can display it like this. There is an official diagram for the has-a aggregation. It's the unfilled diamond. So for example, we might have a classroom object that will contain an array of student objects, and it might be important to diagram that relationship. In this case, we'd read it as classroom has a student. Potentially, classroom has many students. So as with other diagrams, we can optionally have a multiplicity indicator to say that one classroom can have, and we use the asterisk to represent 0 to many students. This is aggregation, and it's very common. And to be honest, it's not always worth showing it on a class diagram unless there's something interesting or unusual about it. But you will see this empty diamond, and that's what it means. Now, composition is also aggregation. Composition is a more specific form of aggregation, and it implies ownership. Now, what does that mean? Let's say we have a document class and a page class. And what we imagine is that a document object will be composed of page objects, made up of page objects. This is composition. Now, what's the difference between aggregation and composition? Well, composition implies ownership. And what that means is when the owning object is destroyed, so are the contained objects. It's still a has-a relationship here. Document has a page or has many pages. But if I were to delete the document object, all the associated page objects should be deleted too. I would not expect then those page objects to be shared with any other part of the application. On the other hand, in a plain aggregation situation, as with the classroom and student relationship, if I deleted the classroom object, perhaps the class got cancelled, I would not expect all the student objects to be destroyed. They may be used in different classrooms or just be able to live on their own. And that's the difference. Composition implies ownership, aggregation does not. Now, aggregation is not usually worth showing on a diagram, but composition often can be. If the lifetime of an object is dependent on another object existing, that can be worth showing, even if we're just prompting the idea that when you're defining the owning class, say here the document class, you may need to write a constructor and a destructor that would take care of creating and or deleting the internal objects.